This is Unit 3, Lesson 2, Systems and Substitution, and we're going to learn how to solve a system of equations using substitution. First, let's talk about a system of equations and what that is. We've already talked about systems, and a system is a group of two or more equations that all relate to one another. In a system of equations, we have a set of equations with the same solution. And the solution of a system of equations is a point that we write as an ordered pair with an x value and a y value. You may remember talking about systems of equations back at the beginning of Unit 2. In that unit, we would graph two equations, and then we would find the point where those two lines cross, and that was the solution. So graphing is one method that you can use to solve a system of equations. We are using the substitution method. In substitution, you are solving one of a pair of equations for one of the variables and substituting that equation into the other equation. So yesterday we talked about the substitution property of equality and said that if A equals B, then B may be substituted in for any expression containing A. If A equals B, then B can be substituted into any expression containing A. So we're taking that idea and we're making it a little bit bigger, but we will be applying the substitution property of equality. Let's start out by going through the steps and looking at an example. We're going to start out with this system of two equations. We have y equals 3x minus 1 and negative 2x plus y equals 1. The first thing you need to do when solving a system of equations by substituting is make sure that you have isolated a variable in one of the equations. Well, let's take a look at the two equations we have. The first one is y equals 3x minus 1. The second one is negative 2x plus y equals 1. If you look at this first one, you'll see that it starts out with just y. The variable y has already been isolated. You only need the variable to be isolated in one of the equations, and it doesn't matter if you choose to isolate x or y. Since the first step is done, let's move on to the second step. We will substitute the value of the variable into the other equation. So we know that y is equal to 3x minus 1. This second step is telling me that I should take 3x minus 1 and place it into the second equation where I see y. So let's write out that orange equation. We have negative 2x plus y, but instead of y, I'm going to do parentheses, equals 1. So negative 2x plus y equals 1. Instead of writing y, we're going to replace it with 3x minus 1 because I was told up here that y is also equal to 3x minus 1. I can replace every single y I see with 3x minus 1. The only thing we have to be careful about is making sure we substitute it into parentheses. So now that we've done that, let's move on to step 3, which is to solve for the variable that remains. The remaining variable I still have is x, so we're going to solve for x. So we will get rid of our parentheses by, I guess, distributing a positive, which changes nothing. And then I can combine these like terms together, so that will give me 1x, or x minus 1 equals 1. I add 1 and find out that x equals 2. Now this is just the first part of your problem. Remember that a solution to a system of equations has an x value and a y value. So we found out what our x value is. We need to go back and find out the y value. And we are going to do that by substituting x equals 2 into either equation that I had at the beginning. Once again, that fourth step is to substitute the found value, in this case the found value is x equals 2, into either equation to find the missing variable. So I can plug it into y equals 3x minus 1 or negative 2x plus y equals 1. I'm going to plug it into the first one because it's already set equal to y, and that will just give me less work that I have to do. So I have y equals 3x. Instead of x, we are going to replace it with 2 because I was told up here that x equals 2. I just figured out x equals 2, so now I'm going to plug it in instead of an x. So y equals 3 times 2 is 6. 6 minus 1 is 5. So I've now found that x equals 2 and y equals 5. My final step is to state my solution as an ordered pair, so in the form x, y. So in this case, my x value is 2, my y value is 5. The solution to this system of equations is 2, 5. Let's go through one more example together. So follow along in your notebook with the steps that we just wrote down as we go through this. My first step is to isolate a variable in one of the equations. Well, once again, I've already isolated a variable in the first equation. X is alone. Like I said, it doesn't matter if we choose x or y. Next, I'm going to substitute the value of the variable. The value of the variable is right here, negative 2y plus 2. Substitute that into the other equation. So I'm going to have 7. Instead of x, we're going to substitute negative 2y plus 2. And then we'll continue. 7x minus 3y equals negative 20. Step 3 is to solve for the variable that remains. So I distribute this and get negative 14y plus 14 minus 3y equals negative 20. I can combine my like terms. Negative 14 minus 3y is negative 17y plus 14 equals negative 20. And now I can subtract 14 to the other side. So negative 17y equals negative 34. If we divide, we find out y equals positive 2. Now that I've solved for the remaining variable, which was y, I need to substitute that y back into either equation. I'm going to use this first equation again because it's already set equal to y, and that just or set equal to x, and that makes things easier. So I have x equals negative 2 times, in parentheses, y, which is 2, plus 2. Lots of 2's here. Negative 2 times positive 2 gives me negative 4. Negative 4 plus 2 is negative 2. Now I need to state my solution as an ordered pair. My x value was negative 2. My y value was positive 2. Now quickly, I just want to look at a couple special situations. If you are ever solving by substitution and you come up with an answer that looks something like this. 3 does not equal 5. That is not true. What that means is that there is no solution. There's no point where those two lines are going to cross because those two lines are parallel and they are going on forever at the same slope. So the answer to something like that would be no solution. If you were to come up with something like 2 equals 2, well, 2 equals 2 is true. That would be the solution of two lines that are perfectly overlapping. If they are perfectly overlapping, that means that they share every solution. Ooh. So that would be an infinite amount of solutions. That would be like having one line, and then directly over it we have another line. And they're sharing all of the same points. So if we have something like 2 equals 2, where the left side and the right side are equal to each other, that's an infinite amount. Something like 3 equals or does not equal 5, where you have two numbers that are not equal to each other, that is no solution.